So you have seen that using cout, we can write something to the console or terminal window. But in real-life applications, we want to be able to read or write data to a variety of sources, not just terminal windows. We want to be able to read data from a file or network and so on. Now, to simplify things, the C++ standard library is designed in such a way that we can work with all these data sources the same way. And this is where streams come in the picture. You can think of a stream as a data source or destination. Now, we have various types of streams, but all these have the same interface, meaning that they have the same functions and we can work with them the same way. And you're going to see that shortly in this section. But before we get started, let's explore a few stream types in the standard library. So if you Google C++ iOS, you will find this page on c++.com. Now, iOS here is not about the operating system of iPhone. It's short for Input-Output Stream. So let's take a look at this page. Now, as you can see, iOS is the base class for all streams. Now, again, we're going to talk about classes in detail in the next part of this course. But for now, you can think of classes as more capable structures. So similar to structures, they can have functions or methods, as well as variables for storing data. So using classes and structures, we can define new data types, okay? Now here we have a class called iOS, and this class extends the functionality of another class called iOS base. So this class is the base class for all streams in the standard library. Now, what you see here that is represented using an arrow is called inheritance in object-oriented programming. Again, it's one of the topics for the next part of this course. But using inheritance, we can have one class inherit all the functionality or all the code in another class. So instead of writing the code twice, we write it once and we let another class inherit that functionality. Now look over here, we have two other classes that inherit the functionality in iOS. We have iStream, which is short for input stream, and OStream, which is short for output stream. Now, using an instance of iStream, we can read data from a stream, and using an instance of OStream, we can write data to a stream. Now, we briefly worked with OStream earlier when we talked about operator overloading. Remember? So OStream is an abstraction for a stream that we can write to. Now, if we click on this, we can see the classes that extend the functionality of OStream. So we have iOStream, which represents a stream that can be used both as the input and output. We also have OFstream, which is short for output file stream. So with this stream, we can write to a file. We're going to see that later in this section. We also have OString stream, which represents a stream for writing to a string. Now at this moment, I don't want you to memorize any of this stuff. All I want you to take away here is that all these stream classes eventually inherit their functionality from iOS and iOS base. So they have the same interface and we can work with them the same way.